the Sphere switched on for the first time, dominating the Las Vegas skyline.
Oh, I don't think he likes it.
But inside the 366-foot-tall dome,
we are not outside. Is that incredible?
Is an even more incredible, immersive experience. The dome holds the world's largest high-definition screen, 160,000 square feet, nearly 20 times the size of the largest IMAX screen. But the screen is just one piece of groundbreaking technology made for this venue. To create content for the screen, Sphere needed a new camera to shoot it. This is the tech behind the Sphere. When director Darren Aronofsky set out to make Postcard from Earth, a movie exclusive to the Sphere, featuring immersive scenes from all around the world, his team started shooting on this camera, or rather, cameras.
When I first showed up, it was 11 reds welded together in a kind of Frankenstein.
But combining the views from those 11 cameras made it difficult to shoot and edit.
So that led us to design the Big Sky camera system, as well as the lens system, to take all those different perspectives on the 11 different lenses, but make it one perspective so it feels like your eyes work.
This is Dinan De Silva, chief architect of the Big Sky camera. He walked us through Sphere's camera lab in California.
That's amazing to have a tool which is so sensitive and be that versatile with it is really just an amazing tool to have.
Filming content for Sphere has two big challenges. It needs a camera that can shoot at a very wide angle and at a super high resolution. To get that super wide angle, Big Sky uses a giant version of a fisheye lens, almost a foot in diameter. It makes a circulinear image, which distorts the view in order to capture a wider angle in a circle. Then, as light passes through the lens, it imprints itself on a sensor, which breaks it into tiny squares of color called pixels. Larger pixels allow the camera to capture more light and more detail. So to capture a higher amount of large pixels for a screen the size of the Sphere, you need a bigger sensor than a screen the size of, say, your phone. Some of those pixels are wasted on a normal rectangular sensor, since a circle doesn't take up the full frame. But
that circle captured from that lens is projected onto the sensor in a circular format, and that circle fits perfectly in a square sensor rather than a rectangular sensor.
The lens and sensor come together to create the massive and super clear field of view needed for the Sphere screen. To test this, we took the camera just outside the camera lab. This is how a camera with a flat lens and smaller sensor saw this area, compared to how Big Sky saw it. The field of view reaches almost behind the lens. Here, you can see a glimpse of Dinan standing just off to the side behind Big Sky.
Instead of shooting horizontally, we tilt up so that we can capture the full field of view that is natural in Sphere for where you're sitting.
The tilt helps the camera line up with the horizon, this line here on the screen. Because when that circular image is transformed into 3D, that is the spot that needs to look the most normal to the audience. The team on set can check that the view looks natural with this, a VR headset that creates a live simulation of the footage on the Sphere screen. But to get a real preview of what the footage will look like in Sphere, the team takes the footage down the street to here, the Big Dome, a quarter-sized version of the Sphere they use for testing. This is a prototype of the screen panels in the Sphere.
They're effectively 32 LEDs in a foot, and when you scale that up to the venue, that's how we get to 16K. That gives the illusion of being there.
Each of these lights make up 1 pixel of the screen, about 170 million in total, that wrap around and above the nearly 18,000 seats in the theater. That makes up the 16K by 16K resolution, which means there are about 16,000 of those lights both vertically and horizontally that translate the pixels captured from the camera into an image. To compare, your iPhone screen only has about 2,500 by 1,000 pixels.
You need a lot of pixels, a lot of detail everywhere, because an audience member might be looking in this direction, another one might be looking in this direction, so everywhere on the screen is an important part of the screen.
And that's not the only thing that makes Sphere so immersive. These holes in the panel allow for sound to pass through, since the speakers are behind the screen, and different sounds can emit from different parts of the screen at the same time. The $2.3 billion venue also has physical effects, like changing temperatures, breezes, and scents, as well as 10,000 seats that vibrate to respond to scenes in the movie. But the screen is the centerpiece. And to create a movie with a huge high-definition camera for a huge high-definition theater, Aronofsky and his team had to think carefully about what they were shooting.
You can't really hide behind anything when you're shooting with Big Sky because everything is sharp. And if there's any mistakes, they're just there.
This shot of a climber on the Alps, for example, took some trial and error.
You're looking over Dwayne the climber and you're seeing this kind of valley below, and without seeing like the depth of the mountains behind, you kind of lost the environment. It didn't feel as risky.
Andrew Schulkind is the director of photography for Sphere and worked with Aronofsky on Postcard.
It felt riskier and more special that he was on this kind of spire in front of this snowy landscape.
That footage eventually made its way to the screen in the Sphere.
I remember we were in the edit when I saw that and got super excited, but we couldn't tell what it was because it was just in 4K. And then we had to go through the process of up-resing it to be able to see it in Big Dome.
Sphere is still perfecting some elements of the camera, like improving its ability to shoot very tiny objects and making it easier to use. But the next big step is getting it onto the International Space Station.
The screen is so big that the ISS can actually fit inside the screen, and so we can convey to people an experience of doing a spacewalk that actually is realistic.
One of the things that we're very interested in as Sphere is to use the venue and the technology for science. And so that's the type of things that we're sort of curious about and will potentially explore in the future.